Hello and welcome back to a new video. In this one, I would like to quickly show what we have been working on regarding the implementation of the logic system. Here you can see the different logic gates we currently have. I'm going to show how they work and how to use them. So over here we have some energy cells. These simply provide a small amount of energy so we can power the logic. Everything is connected to the logic gates using levers as inputs, and on the output we use a debugging lamp to check whether everything works as expected. Let's start with this one. This is an AND gate. You can recognize it by its symbol and also by the different crystal color, which helps identify it easily. If we turn on just one lever, it is not enough. As expected for an AND gate, all inputs need to be on. If any of them is off, the input will not activate. However, if we disconnect one input, for example by cutting this cable, the gate adapts and only consider the remaining inputs. So even though it is supposed to have 3 inputs, it also works with fewer. For instance, here it works with just one input. Next, we have the OR gate. In this case, if any input is on, the output will also be on. Then we have the maximum gate. This outputs the highest intensity value among the inputs. You can see the intensity value in the HUD here. In this example, we have inputs with 1 intensity, 2, and 3. An intensity represents how strong the electrical signal is, similar to rotational speed in mechanical systems. If everything is off, the output is 0. If we turn on the input with intensity 3, the output becomes 3. If we turn off that signal, it becomes 2, and so on. So it always outputs the maximum value. This one is the minimum gate, which works in the opposite way. So it outputs the lowest intensity among the inputs. For example, if only the input with intensity 3 is active but the others are 0, the output will be 0. If we activate multiple inputs, it will always choose the lowest value among them. Okay, next, here we have a NOT gate. If the input is 0, the output becomes 1. If the input is active, the output becomes 0. It simply inverts the signal. This one is a step gate. When we send a signal, it produces a pulse instead of a continuous output. You can configure it to trigger on rising edge, falling edge, or both. Next is a pulse generator. When the input is active, it continuously generates pulses. You can control the frequency and duty cycle, that is, how long the signal stays on versus off. Next, we have here a delay block. When we turn on the input, the output activates after a short delay. The same happens when turning it off. You can also adjust the delay time inside the block. Finally, this is a relay. Here we send an intensity of 3, and this side controls whether that signal is allowed to pass through. So it acts like a switch controlled by another signal. And you can also see that we have different cable colors, 6 in total. Cables of different colors do not connect to each other, which makes building systems much easier and avoids unwanted connections. So that's the current state of the logic systems, and that's all also for today's update. So see you in the next video. Bye.